Hello, dear students. Welcome back to my YouTube channel. Am I audible and visible to all of you? It's Sagi. We have good evening. So I am not able to attend today's class because exam. Because and reason there is no holiday, hence I posted for the not attending classes today. Okay. So I got it now. So today we are having one second. So we are observing something different. 1 second, beta. Me 1 second. So today, hello beta ji, Tanvir, welcome salam. So basically, now look, today we will be completing our chapter, that is current electricity. So from tomorrow we will be starting, or day after tomorrow we will be starting capacitor. Okay. Today we will be having last lecture of current electricity, lecture number 11. So we have completed current electricity in 11 lectures. Okay. So that's why now. So if you have any confusion or if you have any sort of issue with the current electricity, now you can let me know today only. So I guess we need to start now, no? 1 second, beta. 1 second. So let us start today's session. Okay, I guess my screen is visible to all of you. Okay. Look now. So as you know that I am giving you a homework numerical after every class. Then in starting of next class, we are discussing the numerical. So yesterday I have given you the numerical, and the numerical is like n identical bulbs. So we have n identical bulbs, right? So with the line, so I need to understand that one bulb, second bulb, and so on. These are n bulb. Okay, are rated p watt and v volt. When they are connected in series, total power consumed in 20 watts. Total power consumed in 20 watts. As you know that here you can see the series terminal. So what is power in series? Sir, power in series is opposite to of resistance in series. That is, I can write it is power by n. I guess it is 20 by n. First equation. No, no, it is not correct. Why? Because the small power is not given to us. No, this power series is given to us. It is 20 is equals to p by n. This one is equation number first. Now, when connected in parallel, they consume total power 2000 watt. So, what is P series? So, P parallel. Sir, P parallel is given as NP. P parallel is 2000 equals NP. So, from this equation, my P came out to be 20 times N. I can write 2000 N. P is 20 times N. 0 0 cancel out. 2 cancel out. So what we have? We have 100 equals to n square. Therefore, n came out to be 10. Easy numerical. Okay. So this numerical we can done it with couple of seconds. So we have completed now bulbs option also. Let's start now maximum power transfer theorem. What we have now? Maximum power transfer theorem. Look now. What is heat? I need an answer from your end now. Okay. What is heat? Sir, heat is equals to I square into R into T. What is power? Sir, power is I square into R only. Okay, look now. What is current? Sir, current is equals to E divided by R plus R. So can I write now? Can I write now power? Sir, power is equals to I square. I can write E square divided by R plus R whole square dot R. This power, no? I need this power to be maximum. I need this power to be maximum. How to get something maximum? Sir, I guess I need to apply here differentiation part. Okay. Application of differentiation. No? Maxima, minima. Okay. So we can do one thing now. We will differentiate the power. Okay, no issue. I need to differentiate the power with respect to the resistance. So then I need to equate it with 0. This is the format to find the maximum thing. You need to learn this one, right? Okay, sir. So how to get it now? You can see my power. I can write dP by dr equals to d divided by dr of, we have E square into R whole divided by R plus R whole square. We can write like this now. Okay. So dP by d, I need to put it 0, or I will write it dP by dr for time being. Okay. It is U by V format, no? U by V. So what is the differentiation of U by V? Sir, it is V differentiation of U minus U differentiation of V whole divided by V square. So can I write now here E square R outside, differentiation of R plus R square minus R plus R square, then differentiation of E square R whole divided by R plus R square whole square. Yes, sir. Now look, I will place this term as 0. Okay, sir, 0 multiplied with R plus R whole square to whole square equals to E square R differentiation of this term. I need to write it 2 times R plus R 2 minus 1 differentiation of R. Okay. Then plus differentiation of small r minus R plus R square. Then differentiation of, I need to take E square outside constant, differentiation of R is R, right? So 0 came out to be E square R 2 times R plus R, differentiation of R is 1, 1 plus 0. Then we have minus R plus R square, then it is E square only. Okay. I will take E square common, so it will become 0 now. So now equation came out to be, it is R to R plus R, then minus R plus R whole square, or equals to. It will be equals to R 2R plus 2R R plus R whole square. It is 2R square plus 2RR equals to R square plus R square plus 2RR. Cancel out. So we have 2R square minus R square equals to R square. R square came out to be R square. So therefore R equals to R. R is equals to R. Do you know what is the meaning of R equals to R? Do you have any idea about what is the usage or what is the meaning of R equals to R? About this one, no? What is the meaning of it? So the meaning of it is, if we are having a circuit in which my value of external resistance is equals to the value of internal resistance, at that particular instant, my power will be maximum. My power will be maximum. Okay? And this was the derivation part of it regarding maximum power transfer theorem. This is derivation of maximum power transfer theorem. Let us do numerical. Now, let us do numerical. How it will help you in getting an answer, right? How it will help you now. Look now. We have a numerical. Numerical like, I will write the language, a battery of EMF 10 volt and internal resistance and internal resistance 0.5 ohm is connected across a variable resistance R. The value of R for which the power dissipated in it is maximum. Okay. So what will be the answer? What will be the answer? Very easy, no? Or extremely easy. Look better. We have a battery, okay, and the battery is having EMF E, which is of value 10 volt, great, and the internal resistance is 0.5 ohm only. It is connected with a variable resistance R. Okay, so we have a R, right? What should be the value of this R? What should be the value of this R for maximum power dissipation? Sir, I guess the maximum power theorem states that when my capital R value is equal to the small r value, at that particular instant, we will get a maximum power dissipation. So yes, then R should be equal to 0.5 ohm only. Easy, no? Super easy numerical. Okay? Done. Okay, one more numerical. Numerical like, we have a system. Two batteries with same value. Two batteries with same value. 2 volt. Internal resistance 1 ohm. Done. So we are interested in power maximum thing. Power maximum. Okay. Power maximum. So what will be the value of maximum power? We have a system in which two identical cells, 2 volt, 2 volt, with internal resistance 1 ohm, 1 ohm is given, which is attached to the external R. External resistance R. Current is flowing through it. So what will be the maximum value of it? What will be the maximum value of your power? Sir, I guess power equation is P is equals to I square into R. or it is equal to V square by R. Okay, either I need to find out current and R or V or R. Okay, you can see clearly now beta. Look, two batteries connected in series. So what will be the E net? Sir, E net will be E1 plus E2, that is 2 plus 2. 4 volt. What will be the small R net? Sir, 1 plus 1 is 2 ohm. Done. What will be the current now? Sir, current value is equal to E divided by R plus R. E is 4, small r is, sorry, capital R is R, small r is 2. Done. If we are interested in maximum power, we need maximum power. I guess maximum power indicates that value of R should be equal to R. Okay, it is 4 divided by, what is R? Sir, it needs to be 2 equals to 2, no? Yes, sir. 4 divided by 4, that is 1 ampere. So resistance I know now, current I know now. I guess I need to use this equation. So P equals to I square. What is I? 1 square. Into, what is R? R is 2. R, na? Look, R is 2. I guess my answer is 2 watt only. I guess my answer is 2 R only. Yes? Okay, now? Okay. One more numerical. One more numerical. Vidansh Rastogi. Better do one thing, na? Just message me in Telegram, okay? There we will have a talk about it. So we have a system now. We have system now. This numerical is combination of various concepts. Done. Four ohm. R, 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 4R, 6R. Done. So for maximum power, question is for maximum power, what needs to be the value of this R? Okay. For maximum power, we need to get maximum power. What should be the value of this R? Done now? One thing that we know that, sir, whenever we are talking about maximum power, so my R should be equal to the small r. Okay, small r is 4 ohm, but what is capital R? Capital R is the equivalent resistance of your system. That means I need to only find the equivalent resistance. Look now, you can see here, sir, R plus R, these two R, these are in series, so I will write 2R. R plus R, 2R in series. Now look about R divided by 2R. So I can write R divided by 2R. 2R divided by 4R. 2R by 4R. 2 ones 2, 2 twos 4. Okay. It equals to, look, this one is 1 by 2. This one is also 1 by 2. Balanced. So you will write here balanced Wheatstone bridge. So there is no use of this 6 ohm. What we have now? We have R. We have 2R. 2R plus 1, that is 3R. So we have 3R. Here 2R, 4R, 6R. So 2R and 6R, these are in what? Parallel. So what will be the equivalent value of 3R and 6R? What will be the equivalent value of 6 and 3R? Sir, it is 3R into 6R divided by 3R plus 6R. Okay, it is 18R square. It is 9R. 9 or 9, 9 to 18. So my answer came out to be how much? It is 2R only. That means, so I will write here, sir, 2R is equals to 4 ohm. 2 1 is 2 to 4, so R is equals to 2 ohm. So if I need a maximum power for this system, the value of R, each R needs to be equals to 2 ohm. It should equals to 2R. Look now. So look, we discussed here maximum power transfer theorem, but we included here a concept of balanced Wheatstone bridge. Okay. Now, one thing that I told you already now, that is, look, brightness. That is brightness of the bulb. So brightness is directly proportional to the actual power that is coming to your houses. Brightness proportional to the actual power, and actual power is V square by R. So V square actual voltage divided by the resistance of your bulb, which is equals to I square actual into R. So if you need to find the brightness of your bulb, so this equation you need to memorize. So the brightness is directly proportional to the actual voltage, which is proportional to the V square by R, and I square, sorry, it is I square into R. This thing you need to memorize. Okay. Okay. So let us do a couple of numericals on it. No, couple of numericals on brightness. You will find a numerous numericals based on the brightness system in your all examination formats. Whether you are talking about NEET, JEE, okay, you will find. So here, let us merge some concepts now. First, we will talk about series. We will talk about series. So if we are having two bulbs, look, one bulb, second bulb. We are having two bulbs with, let's suppose, some voltage V. So current I will pass. The same current will flow through both the bulb. If this bulb is rated as 60 watt and 220 volt, this one is 100 watt and 220 volt. You need to tell me that which bulb will glow more. Which bulb will glow more? Sir, as we can see that current is same. Current is same flowing through both the resistors or both the bulb. Okay, sir. So one more thing that we know, sir, brightness. Brightness is proportional to the power actual, which is proportional to the V square by R actual, proportional to the I square into R actual. So here, I guess there is no use of power or V. I can use this equation, no? Why? Because I square is common. Okay. So I can write brightness. I can write brightness is proportional to the I square into R. I is common in both, so I can write brightness. I can write brightness is proportional to the R. More resistance, more brightness. So by this equation, you conclude that if we are having more resistance, the more resistance bulb will give more brightness. More resistance bulb will give more brightness. Done? Okay. And do you know one thing? What, sir? power is equals to that thing that we discussed in previous lecture, no? The power that is rated, power rated is inversely proportional to the R. Why? Because power rated is equals to V square by R. V rated, look here, 220 volt, 220 volt. Sir, V is common, so power is proportional to my resistance. So that means brightness proportional to resistance. Resistance is inversely proportional to the power rated. So I guess 60 watt power is less than 100 watt. So power of first one is more than power of second one, which indicates the resistance of first one will be low resistance of second one, which indicates the brightness of first one is less than brightness of second. Yes or no? Yes or no? Huh? Yes or no? Asana beta, I'm asking you, no? Right? Is this correct? Is this correct? Huh? No, it is not correct. Why, sir? Because I will tell you, na. Look, I will tell you. Why, sir? You can see now, power of first one is less than power of second one. So power of first one is less than power of second one. That means resistance of first one is more than resistance of second one. So brightness of first one more than brightness of second. See, you are saying that sir is giving us the answer. It must be correct, no? I'm manipulating your values here, right? I need to know na, that whether you are paying attention to the class or not. You are just enjoying like a movie here. No. Okay. This is how you need to do your numericals. If we are having series, so brightness is inversely proportional to the power rated. So this thing we need to take care of it. Now, sir, if we are talking about parallel one, if we have parallel, right? Look now. If we have parallel one now, this one is 100 watt, 220 volt, 50 watt, 220 volt. Look here. I guess here voltage will be same. Parallel, na, V will be same. So I can write, sir, brightness is proportional to the V square by R. But V actual, because brightness is depending on the actual parts. Done. V is same. So can I write now brightness is inversely proportional to your resistance? This thing we need to know. And our power rated is inversely proportional to the resistance. We done this one now, no? So which therefore it indicates that my brightness is proportional to a rated power. So look, 100 watt, 50 watt. So you can write, sir, power of first one more than power of second. So that means brightness of first one more than brightness of second. This is how you need to tackle with your numericals. Okay, one more interesting numerical. If we have a system like this, if we have a system like this, look now. Then with values R, V. When this key is not closed, first part, key is open. Then second part, when we close the key is closed. what will happen to the brightness part? First part, when key is open. Second part, when we tap the key and when we close it. What will happen to the brightness? Look here, I guess current I will flow, right? So same current I will flow. If I is same, so which equation I need to use now? Which equation here? Sir, I guess power is actual equals to brightness equals to I square into actual into R. That means I need to use this equation. Okay. So brightness proportional to the I square into R. I will be same. So brightness is proportional to my resistance part. First case, when key is open. When key is open, this one, and this one, all three are in series. So I can write R equivalent in first case. R equivalent is 3R. So what is V? Sir, Ohm's law, V equals to IR. V is V, I is I, R is 3R. So my I came out to be V by R, 3R, right? So can I equals to 0.33 times V by R? When key is closed, I close the key. Look now, if potential of this one is, let us suppose A, so potential of this one will be also A. Potential of this one will be also A. Potential of this one will be also A. So no current will flow through this one now. So what will be R equivalent? Sir, it is 2R only. What will be V now? V equals to IR. V is V, I is I. What is R? R is 2R. So can I write now? I came out to be V divided by 2R. I came out to be 0.5 V by R. I1, I2. I guess I2 is more than I1. So in second case, when we are closing the key, what will happen? Sir, current increases. Current increases. Done, no? If current increases with the current, brightness increases. So my brightness also increases. Okay. Look, this is a real procedure how you need to tackle with your numericals. Easy or tough? Huh? Easy or tough? Easy or super easy? Hmm? Okay. So let us just relate 11th concept with 12th now. From the previous class, no? Let us have one more numerical. We have a lot of time now. We have 1 hour left now. Suppose we have a question. We have a bulb. This is my bulb with 220 volt voltage and power is 100 watt. Okay, done. Power is 100 watt. If voltage drops, by 2.5%, if my voltage drops by 2.5%, done, of a rated value. That means we have a rated value of voltage, that is 220. If now voltage decreases by 2.5%. So what will be the effect of percentage change in power? We know that power depends on the voltage. No? If voltage changes by 2.5%, what should be the percentage change in power? So we know that if change is less than 5%, if change is less than 5% or equal to 5%, we use dielectric formula. That means, sir, power is equals to V square by R. Done. Resistance is constant. Why? Because bulb is same bulb, same filament, same resistance. I can write delta P by P into 100% equals to 2 times delta V by V into 100%. To delta V by V 2.5% into 100%. No? I guess your answer came out to be 5%. It decreases, not decreases. So if your voltage drops by 2.5%, your power will decrease by 5%. Done? Power decreases by 5%, double of your initial value. Clear now, beta? Huh? Okay. Now let us discuss one more interesting topic known as Kettle problem. Kettle problem. Do you know what is kettle? Okay. Something like this. Then we are just connecting this with the plate of it. Inside we have water. This water start boil. Okay. In winters, no, we usually use it now to boil the water. Kettle problem. So in kettle problem, we encounter many numericals in which we need to find out the time. What should be the arrangement of this kettle so that we will get the minimum time things, right? To understand kettle, what we need now, it is based on the heating effect. It is based on the heating effect. When current will pass through the coils, coil will heat, that heat will boil your water. That means, sir, heat is equals to V square by R into T or I square into R into T. Done? Done, no? If you are using this kettle in your homes, I know that the voltage is 220 volt, no? It is fixed in India. In India, it is fixed at 220 volt. In USA, it is 110. So in India, it is fixed. So all the applications that we are having in our home, those are designed based on the 220 volt. Okay, sir. So that means 220 volt is fixed. Sir, it is fixed. It is fixed. Done. So what is heat? From 11th standard, is it ms delta T equals to V square by R into time. This is time T. Look, if we are having kettle, it is having some mass of water, no? Water. So water is fixed. Specific is fixed. If I need to increase the temperature by 10 degrees centigrade, that means it is fixed. Delta T is fixed. V is fixed. So therefore, my time is proportional to the resistance. Time is proportional to the resistance. Let us suppose we talk about the two coils, right? We talk about two coils. First case, if we are connecting the coils in series, what will happen to the time? Okay. So if we are having two resistors with resistance R1 and R2, what will be R net? Sir, we know that it will be R1 plus R2. Same, time will be T1 plus T2. Why, sir? Because it follows this relation. No? It follows directly proportional relation. Second one, if we are placing them in as parallel, so one resistor, second resistor with R1, R2, what is R equivalent? Sir, R1, R2 divided by R1 plus R2. That is T net equals to T1, T2 divided by T1 plus T2. Done? It is not that important, but still it is important. You need to have some idea about what kettle problem. Let us suppose you will find a numerical and based on this particular parameter. You should know now how to deal with it or which formula or how to think about it. Sir, why we need T1 plus T2? Why is it T1 plus T2 divided by T1 plus T2? You need some idea behind it, no? You need something, right? You will find numerical based on it, no? Okay, let us suppose we have a numerical. We have a numerical, and I will write the whole definition or whole parameter of numerical. It states that we have an electric kettle. An electric kettle. You will see the language of your numerical. Has two heating coils. Two heating coils. When when one of the coils is connected to an AC source, the water in the kettle boils in 10 minutes. In 10 minutes. When the other coil is used, the water boils in 40 minutes. In 40 minutes. If both the coils are connected in parallel, the time taken by the same quantity of water to boil will be. So the language of the numerical will be like this. We have an electric kettle. Okay, so I need to use the concept of electric kettle. Then it has two coils. Then when one coil is used, the water in the kettle boils in 10 minutes. That means T1. T1 is given as 10 minutes. Okay, sir. When the other coil is used, the water boils in 40 minutes. So it is 40 minutes. When we are just connecting them in parallel, so what is T net in parallel? Is it T1, T2 divided by T1 plus T2? T1 is 10, T2 is 40, divided by it is 10 plus 40. It is 400 divided by 50. It is 8 minutes. That means you will get 8 minutes. How many minutes you will get? You will get 8 minutes to boil the kettle in this format. If you are connecting your coils in parallel, you will get the minimum timing to boil your water. But if you just connect them in series, timing will be 50 minutes. Okay, this is how you need to do your numericals. So let us start the last topic of your chapter, that is galvanometer. That is what? Last topic is galvanometer. What happens to it? Once again. One galvanometer. It is galvanometer. I guess you know now what is galvanometer. It is a device. Galvanometer is a device used to detect or measure small amount of current. Then galvanometer, we use it to calculate or to detect a very small amount of current. Okay, and the galvanometer looks like this. We have something like this, G, and it is functioning, or all these things you will get in next chapter. So this is my galvanometer. Current I is going through it. So this current is galvanometer current. I can write IG. This galvanometer is having some resistance. I can write resistance of galvanometer RG. And voltage across or potential drop across this G will be VG. What is IG? IG is full scale, its name, full scale deflection current. Full scale deflection current. What is RG? RG is resistance of galvanometer. What is VG? Full scale deflection of voltage. So one thing that we know from Ohm's law, and we stated that V equals to IR. It is not V, it is VG. It will be IG and RG. So we have to use this equation in our galvanometer topic. Done. Okay, this is all about our galvanometer. All about the galvanometer. Now, if let us suppose we want to calculate a bigger amount of current, it is not compulsory always we have small amount of current. Okay, suppose we want to increase its value, we want to calculate a more valuable current. How we can do it? So we have to manipulate, or we need to add something to the galvanometer so that we will calculate the more amount. Galvanometer is the basic of the instrument, basics. So topic is how to convert galvanometer to ammeter. How to convert galvanometer to ammeter? It is very simple. Sir, this is my galvanometer that we know. And current Ig will flow through it with resistance Rg and voltage Vg. If I will place a resistance here, one more resistor here, parallel to it, name of this will be S, and its name is shunt resistance. Shunt resistance. So what is shunt resistance? Shunt resistance means it is a resistor which is placed parallel to our ammeter. Done. And its value is very small. Small resistance. So why it is value small? Because if current I is coming, so the value and the property of galvanometer is it will only detect small current. If we are trying to get more current towards it, it will burn. So maximum current should need from this one and with least opposition, that means least resistance. So this current is I minus Ig. So how we will write now? Sir, we know that potential across G and potential across S is same. Why? Because both are in the parallel condition. I can write potential across galvanometer equals to potential across shunt. Vg, what is Vg? From previous it is Ig Rg. What is Vs? It will be I minus Ig into S. I will write Ig Rg. Done. Divided by I minus Ig. This is how you will find the value of shunt. This is how you will find the value of shunt. What is shunt? Ig Rg, I minus Ig. If somebody will ask you, what is a resistance of it? What is resistance? Look, this yellow box is ammeter. So I guess it is having two resistors. Yes, sir. G and R, or Rg and R. Both are in what? Parallel. So what will be the R net? Sir, R net will be Rg into S divided by Rg plus S. This will be the net resistance of your galvanometer. This is very easy, no, beta? And its value is small. Its value is very small. Small value. Why? Because S is small, R is small, S small, R small. Small is very small. If somebody will ask you what is the ideal ammeter resistance, ideal ammeter resistance is 0. Look, ammeter is having very small value. No? If we talk about the ideal means 0 resistance. This thing you need to keep in mind. Let us do now some numericals. Okay. Let us do some numericals. And numerical like, we have a galvanometer with resistance of galvanometer is 60 ohm is given to us. Current through galvanometer is 1 ampere. Total current is coming 5 ampere. Find the value of shunt. Sir, how we can do it? Look, we know shunt. Now what is shunt? Shunt is Ig into R divided by I minus Ig. What is Ig? It is 1 into R is 60 divided by I. I is 5, 5 minus 1. It is 60 divided by how much? 4. It is 4 ones are 4, 4 ones are 4. 10. No? I guess it is 60 minus 4, right? It will be, 5. So my S came out to be 15 ohm. It is 15 ohm. Done? Easy or tough? It is easy or tough? Huh? One numerical. I will write the language of numerical firstly. Look now, a language is like in an ammeter 0.2% of main current passes through the galvanometer. If resistance of galvanometer is G, the resistance of ammeter will be. That means, look better, how we can solve it? Let us put some different approach to it. Different approaches. We firstly make a galvanometer, right? Galvanometer. Shunt. This shunt galvanometer. So if current I is coming, so 0.2 I will go here and I minus 0.2 I will go here. So we know that sir, potential across galvanometer will be across potential across shunt. What is Vg? Vg is I into R. What is I? I is 0.2% of I into G. What is Vs, sir? Vs, I guess it is I minus 0.2% of I into shunt S. Done, no? Okay. I write 0.2 into 1 divided by 100 into I into G equals to 1 I minus 0.2 divided by 100 I into S. I can write 0.2 divided by 100 into I into G equals to 100 I minus 0.2 times I divided by 100 into S. 100 cancel out. It is 0.2 times I into G. It will be 99 point. It is 0.2, no? 8 times I into S. So I guess I will write now S, I cancel out. So S equals to 0.2 divided by 99.8 times G. Cancel out point. So we have 2 divided by 998 times G equals to 2 ones are 2, 4s are 8, 18, 2 another 18, 2 another 18. So by this equation, you will write shunt is equals to G divided by 499. Look, this is the resistance of shunt now, but I need to find out resistance of ammeter. What is the resistance of ammeter? Sir, R net is equals to R1 R2 divided by R1 plus R2. R1 is resistance, no beta? It is G. R2 is G divided by 499 divided by G plus G divided by 499. It will be G square by 499 divided by 499 G plus G divided by 499. Cancel out. So my value come out to be R net, na? So R net is equals to G square divided by 500 G. G cancel out. It is G divided by 500. This is my value. This is my value. I hope you understood this one. And if you have any confusion, you can just let me know. Done? So I am so much confused. I can't understand Kirchhoff's law. Beta, Divansh, do one thing, na? I guess back, you need to go 3 classes back. You will find Kirchhoff's law, KCL and KVL. And we have done couple of numericals based on KVL and KCL, okay? There are numerous numericals that we have done based on these principles, na, Kirchhoff's law. And it is very easy, right? Okay, now one more instrument is there, that is voltmeter. That is what? Voltmeter. Voltmeter is used to measure. It is used to measure potential difference. Use it to measure potential difference. And if we talk about ideal voltmeter, it is resistance is infinite. Done? Okay, infinite. But if we talk about practically the value of R is very high. Sometimes you will get some numerical, na? What is the practical value of your voltmeter resistance? That is very high, extremely high, but not infinite. Okay, so how to make now voltmeter? Look, voltmeter, it is basically a galvanometer. Then we are using a high value resistor in series of it. Okay, this is my galvanometer. Galvanometer. This one is high value resistor. High value resistor. That will be good, no? That will be good. I have given you 11 classes of current electricity. Do watch the from first one. Okay? And you will find something new in the classes because I am going to the point. I hope that you will get it now. Look now, sir, we know that the current which will flow through galvanometer is known as Ig. It is Ig now. Potential across whole potential. Now, this one now, the whole thing. This whole thing is known as voltmeter. Whole thing. Okay. This value is R. And it is very high. It is extremely high. Very high. Then resistance of this one is Rg. Okay. So what is V? Sir, V is equals to I into R. V. I is I. Look, I is basically Ig. R. This Rg and this R both are connected in series. So I can write it is Rg plus R. Done. I can write V divided by Ig is equals to Rg plus R. Therefore, if you want to find R, so R is equals to V divided by Ig minus Rg. Remember this relation. Remember this relation. This relation, we can use it to calculate the resistance of the high voltage thing in your voltmeter. Okay. You will find one more thing now, that is division thing. I will tell here now. It is very rare, but you will find division thing. That is, suppose this will be given to you. What's that? In a galvanometer, the total divisions is 40. Done. And current through one division. Current through one division is 2 into 10 to power minus 3 ampere. What is value of Ig? So how many divisions we have? 40. And in one division, what is the amount of current flowing? 2 10 to power minus 3. So this is your Ig. Okay, so you need to understand that how to get my Ig also. How to get my Ig also. Let us do a numerical, 2-3 numericals. Okay, then we will finish the whole chapter. Let's do 2-3 numericals. Look now. Look beta. Suppose we have given a galvanometer, and the galvanometer's resistance is, let's suppose, 100 ohm. Done. And current which is flowing through galvanometer, its value is 30 milliampere, 10 to power minus 3 ampere. Done. And potential difference is given as it is 30 volt. Find the value of R in voltmeter. In voltmeter. Sir, we know that R is equals to V divided by Ig minus Rg. What is V? Sir, V is 30. Ig is how much? 30 into 10 to power minus 3 minus Rg. What is Rg? Rg is 100. Cancel out. So I will write 1000. No, it is not 1000. No. It is 1 divided by 10 to power minus 3, 10 to power 2. I will take it up. It is 10 to power plus 3 minus 10 to power 2. It is 1000 minus 100. Answer is 900 ohm. Answer is 900 ohm. Okay, let us do one more numerical. And this numerical I will write now. Whole language I will write now so that you will get a better understanding of numerical. A galvanometer. A galvanometer of 50 ohm resistance has 25 divisions. 25 divisions. A current of 4 10 to power minus 4 ampere gives a deflection of 1 division. To convert this galvanometer into a voltmeter having a range of 25 volt, it should be connected with a resistance of. Okay, so what we need to find out? Value of capital R. We need to find value of capital R. Okay, so I guess capital R is equals to which value? V divided by Ig minus Rg. Okay, V is given to us. I will find now. Is V given to us? Yeah, 25. Okay, sir, it is 25. Current is not given to us in Rg. Rg is how much? 50. 50 is given to us. What is Ig? In one division, in a Y division, what is current? 4 10 to power minus 4. Done. And in 25 divisions, how many we have? We have 25 into 4 10 to power minus 4. So I will write 25 divided by 25 4 10 to power minus 4 minus 50. Cancel out. So R is equals to 1 divided by 4 10 to power minus 4 minus 50. Done. I will write R equals to 10 to power 4 divided by 4 minus 50. It is 10 to power 4 minus 20. It is 200 divided by 4. 1, 2, 3, 4 minus 200 divided by 4. I guess it will come out to 10,000. It is 2450. Yeah, I have done this numerical now. I know the answer now. Okay. Done. So I guess we have a couple of minutes. So we will do one last numerical. One last numerical, then tata bye bye from this class. From current electricity. One more numerical, last numerical. A galvanometer. We have a galvanometer of of resistance 50 ohm is connected to a battery of 3 volt along with a resistance of 2950 ohm in series. A full scale deflection of 30 division is obtained is obtained in the galvanometer in order to reduce this deflection to to 20 division to 20 division. The R value should be. So a galvanometer is having resistance 50 ohms. So I will decode now. I will write the value of it now. So sir, the value of R is how much? Rg, it is 50 ohm. No issue. So V is given to 3 volt. Okay. And R is given 2950 ohm. Done. In series. Okay, we know that. A full scale deflection of 30 division is obtained in the galvanometer in order to reduce this deflection to 20 divisions. Okay. So we have to find out the current firstly. I guess V equals to IR. Okay. What is V? V is 3. I is I. What is R? R is 2950 plus 50. 3 equals to I. It is 3000. I came out to be 3 divided by 3000. It is 1 divided by 1000 ampere. That means in 30 division, my current is 1 divided by 1000 ampere. So in 20 divisions, so I guess we have how much? In 20 divisions, no beta? Yeah, in 20 divisions. What I need to write now? One second. Okay. That means, look, in 30 divisions, 1 by 1000 in 1 division. I've read 1 divided by 1 is 10 is 100,000 into 1 divided by 30. In 20 divisions, it is 1 divided by 1000 into 1 by 30 divided by 20. Cancel out, it is 2 divided by 1000 ampere. So I got my current now. Okay, I got now current now. So I need to find R now. I guess V equals to IR. This equation we know now. V is how much? 3. I is 2 divided by 3. It is 2 divided by 3000, not 3000. It is 3000. R, what is R? Sir, R is 50 plus R. Okay. So I will write it as 3000 into 3 divided by 2 minus 50 equals to R. 9000 divided by 2 minus 50 equals to R. 4500 minus 50 equals to R. It is 4450 ohm equals to R. Done? So by this numerical, we conclude current electricity. So I will write here. No, not this one. 1 second. Current electricity. completed. Done. And next we will start capacitor. If you have any doubt, you can reach out to me Telegram. You can write Shakoor Sir Physics. There you can give me, okay, your suggestions or if you have any issues, right? So we completed this one. From next class maybe tomorrow or the day after tomorrow, we will be starting capacitor. I hope you got something good in the classes, no? I'm trying to give you some quality content for your examinations. Okay, direct things. I'm not defining so much things, no? Because I know that you must know that little bit of the definitional part, and I'm not giving you something that is not relevant to your examinations. I'm giving you to the point thing. Okay, I guess you have seen. No? Look, we are doing some topic. Then from the topic we are doing some numericals, so that you will get both things. One is the theoretical one is the application part of it also. You should be very good in both, no? Good in both. If let us suppose you are not good in derivational part or you are not good in defining something, so you will get very less number in your board examinations. But if you are having the capability of writing signals, if you have the capability to express what you have in your mind, that is good. You will get a very good number in your board examination. But if you don't have the things how to manipulate with the numerical and how to get the answer, you will get a very bad number in your competitive examination. So you need both things, theoretical thing one also, and your practice numerical way also, so that you should get both things. No, board numbers more than 95%. Your need more than 95%. That is very good thing, no? And definitely you will get by trusting your teachers and by getting your module done, DPP done, NCRTs done, and your PYQs of NEET, JEE mains, and this easy of IIT also. If you can do these things, and definitely you will crack any examination in the world. But you need to have some sort of zest for any examination or any preparation. But if you are just doing some time pass, no, that is not good for your future also. Okay, I hope that you have understood, I guess, everything from the class. If you have any confusion or if you have some issues with my class or anything like that, you can just reach out to me. Again, I have given you my things. So thank you, beta. Thank you. Bye. Good night. Okay. And I'm also thinking now that I will start a lecture end thing. That means uh, I will take 100 or 200 numericals from a particular chapter and I will discuss it on a very particular day. So we had completed the electrostatic, then we have completed now this electric current also. So what I am just thinking now that I will just start a one lecture. In that one lecture, we will be discussing each and every type of numerical from electrostatic. 2 hour lecture or 3 hour lecture. One more day, we will be doing the same with the current electricity. Okay, so we will be doing top 200 or top 100 numericals. Then so on and so on. If you have any suggestion from your end also, if you have anything from your end also, so you are most welcome. Okay, just drop your comment. I am just seeing the comment on the regular basis. And if you want to ask me anything about your examination or any issue that you are facing, you can just go to my Telegram and you will find my personal link of Telegram. No? Then you can ask me your doubts. I'm always available for you. I hope we have discussed more than enough. No? Thank you, beta. Thank you very much and good night. Bye. Take care. Bye, beta.